Good morning, everybody. Thank you for joining us here. I'm fine. We are the Turbo Encabulators. My name is David Jacobson. These are my colleagues.
Sebastian Perez.
And Nishan.
Again, we are the Turbo Encabulators. We set out with the idea to build a turret. For some background on this, we wanted to build something that reflected the current state of robotics. Robotics involves many different types of engineering, but it also involves military. And one of the biggest advances recently has been is drones, autonomous things to replace manned infantry. So we can put machines in place which are expendable and relatively cheap, instead of putting human lives on the line. Now, before we even proceed, we would like to give huge thank yous to people who this would not have been possible without. So I'd like to give a huge thank you to Professor Jonathan Liu for just being the most amazing helper. And thank you, Mr. Martin. And thank you, Mr. Johnson. All the behind the scenes. All as always. Go ahead.
So, what does the actual outside of the turret look like? What you're going to be seeing, the mechanical structure of the turret, not what's going on in the inside with all the coating and all of that, but what's on the outside. So, from top to bottom, we have the actual turret portion consisting of the firing nozzle, the servos which are going to rotate this when it goes into detection mode. We have the battery, and we have our two hardware processors, which we'll get into later. Right below that, we have our servos and the battery. These are going to form the core, the heart, lungs, pancreas, liver, gallbladder, whatever. This is the core of our turret. Below that, we have our quad pod, custom made by Nin and myself out of wood popsicle sticks, screws, and metal connectors. That's what the turret's actually going to stand up on. And then under that, here on our cardboard sheet, we have all of our circuits. We have breadboards with all of the wiring running in and out into various processors and into the servos themselves.
So we used a lot of mechanical stuff for our turret. As you can see right here, that's an ultrasonic sensor. It's used to detect our targets, as you would say, and it tells us how far away the target is from the turret, so we have a good idea of what angles we need to use for our servos in order to successfully hit the target. We also have two servos, as my colleague Sebastian said earlier, and one of them is being used to move the turret on the y-axis, one of them is being used on the x-axis. The x-axis servo moves from 0 to 180 degrees, and the y-axis moves from 0 to 90 degrees. Both of them move at 10 degrees.
Okay, so I'll discuss the movement of the turret. As my colleague Sebastian mentioned, we have the servos which move on the x and y axis. They move in intervals, and we have the sensors that was discussed. I'll talk about the Raspberry Pi Arduino. So the first thing we have here is a Raspberry Pi. This is a small computer that runs an operating system known as Linux. We programmed everything on there in Python. We had to do something which was a bit complicated, which was pipe a lot of data over to a smaller thing that I don't know if is in view right here. This is an Arduino. It doesn't actually have an operating system on it. It's basically running directly on hardware. So because the way the servos work, we can't actually tell it to go to 30 degrees directly. We have to use something called PWM, pulsing with modulation, which is where you send a specific amount of current for a very specific amount of time, like 0.001 seconds, and that will turn it towards that angle precisely. But the problem is when you have a Raspberry Pi, which is doing so many other things concurrently, you're not able to get that. So we had to pipe it over this Arduino, and then we had to share the power. So because there's so many intricate parts of this, we also had to have a battery which powers it externally. I'll discuss the summary of the code. So the bulk of this was written in Python, which is an object-oriented language. To avoid some of the technical details and just give a brief overview, one of the main advantages of this language is that we can represent real-world things with blueprints in code. So for each physical component of this robot, I've written what's called a class. There's a class for the servo, which means if you look right here, I have to write 2 lines to get everything to work. Now there's more under the hood, but it makes it extremely readable and portable and scalable, which means this is great for long-term projects. We also had to write things in C, which is a much lower level language, which means we're writing to hardware. It was a very arduous task that took many, many hours, as Professor Liu remembers.
Over the time we've been working on this turret, we made a lot of additions to our ideas, and some of them, as you can see right here. So, as we probably all know, automatic things will always fire automatically. Something might go wrong, and because of that, we added a switch, as my colleague David is picking up right now, you might see. That is using a manual override in case something goes wrong. We can turn it off, and the turret will not fire. We also, as my colleague Sebastian mentioned earlier, we also worked on a custom-made tripod due to time constraints, and we couldn't buy our own tripod, so we made one ourselves.
Indeed, we are very happy with the state of the tripod itself. We originally were going to buy one, but we do feel that making one ourselves to custom fit the turret was indeed the way to go. You'll see up there we have the Arduino. Unfortunately, although this project in the beginning was to set out to build something using a Raspberry Pi and not Arduino, we did have to kind of turn over to the dark side a little and use the C programming language instead of Python. And I'm sure David would tell you all about why Python is preferable. But we did end up adding Arduino in late in the game. We also have numerous minor fail-safes on the mechanical standpoint, restructured gluing, etc. Overall, giving us an astronomical factor of safety of around 2.17. Of course, plus or minus about 99%, but it's pretty safe.
And with the addition of ideas, sometimes you have to take out ideas that may not work. And so, you can see the list right here. A joystick was going to be used as the original manual override idea, but because of time constraints and because we thought it would be a lot harder to program, we decided that a switch would be much easier to use. 7-segment displays, we were originally considering not using them in the first place, or taking them out, but since we could not glue them to the back, but they are fully operational and working. They're on the breadboard. You can't really see them under the turret itself. Also, we were originally going to use a tread in order to move the pellets around so that we could fire them using the tread, but we figured that the tread would be too slow to actually fire given the momentum in the fire, so we used a really high power motor that uses torque. It converts RPM to torque. And a laser pointer, we were also originally going to use that, but we decided not to early on. As you can see here, it's a comparison of our two lists. On the left, you can see our original ideas that we wanted to use when we proposed this idea. And on the right, you can see our final list and everything that's on this turret. And now for your feature presentation.
Demonstration, rather. As of now, there is no other loading mechanism because of time constraint, so we have to manually load the pellet in. As it detects an object in front of it, it will raise up, pull back. Oh, we gotta turn this on. Detects an object, and there we go. It doesn't fire that consistently, not always at the best range, but that's the pellet. And we'll be presenting it more in the back.